Hmm.
So I have an icon that still says start webinar on my screen.
It says that on
You see
mine
that?
as well. I'm kind
Okay.
of unsure. I keep hitting the start button and it says, let's
And
get
nothing happens.
started.
Okay.
Throwing me? For everybody who has already joined, we're just going to give it another minute or so for any last minute people connecting, and then we'll get started. I'm really excited to have you with us this morning. All right. It really looks like our number is about evening out. So I'm going to go ahead and have us get going. Um, Good morning, everybody. Thank you for joining us today. My name is Gretchen Hahn, and I am a recruiting specialist in the Graduate College of Engineering. I'm joined by some wonderful members of the chemical engineering faculty and PhD program. You're going to get to hear from them here in a little bit. And this is our fall 2024 Wonder Week. Thanks for joining us. I'm going to go ahead and hop right in before I turn it over to my colleagues in chemical engineering with just a little bit about Northeastern University for anyone who maybe this is their first time getting some information on us and what it is that we have to offer, specifically in chemical engineering. Northeastern is a top-ranked R1 research and experiential learning university. That experiential learning component is primarily achieved through our co-op program. We are ranked #1 in the country for co-op and internships. There are 10 colleges and schools across the university with over 50,000 students. And the degrees range from a bachelor's degree all the way up to the doctorate level. As an R1 research institution, our external research awards are around $282 million. And though we are primarily in Boston, that is where this program is housed, we have a whole global university system of 13 different campuses. You might be wondering what a global university system looks like. And for us, that is a series of graduate campuses across tech hubs all over the country that are helping us bring engineering and other tech degrees to those sort of thriving areas. You can see a huge group of our campuses listed here, lots of opportunities to study across these places with a lot of our different co-op partners as well. And before I get ready to turn it over, I just want to talk about the COE mission. It's something that we think sets the tone really well going into these webinars. As an academic institution, our main product is people. Our success is based on the quality and the quantity and the quality of the people we produce. And so in the College of Engineering, we know that good engineers solve problems and great engineers can solve important problems. But at Northeastern, we are looking for the transformative engineer who can discover and solve important problems. Again, these are all of our areas of engineering that we offer within the College of Engineering, all of our different departments. You are here to learn about chemical engineering today. And then these are just some fast numbers of sort of the overview of the College of Engineering. We are a number 38 best ranked engineering graduate school, and 37 there for engineering undergrads as well. You can see our numbers a little bit there on the screen. I won't go through all of them with you, but again, PhDs and master's programs available along with the bachelor's level, a myriad of full-time faculty, and over 110 academic degrees, certificates, and minors to really help you study just every little thing that you could want. Another breakdown of some of the programs that are offered specifically across our global campus network in particular, in terms of the type of engineering you can do there. Because we only have chemical engineering in Boston, probably not the most pertinent thing to this conversation, but it's always good to know. And we're constantly expanding on all of these campuses. We're excited to bring more and more programs to more areas of the country and beyond. And with that, I'm going to turn it over to my colleagues in the Department of Chemical Engineering.
Well, hello, everyone, wherever you may be, whatever time of day it might be where you are. And I'm happy to have you join us here potentially in Boston. So next slide. Today we're going to hear from myself. I am a teaching professor in the department and teach some of the master's level courses. And also I'm the associate director for master's programs. We'll also hear from Dami Darmola, who is one of our tenured track faculty and engaged in research. And then we'll also hear from Mallory, who is a current PhD student and one of our graduate ambassadors. There's some fast facts on the department there. You can see we are currently at about 100 PhD students, over 50 masters, and close to 400 undergraduates. And the last line really indicates that most of our students are going to do a co-op, and it's really a key part of the educational model here at Northeastern, and that's true in the graduate programs in addition to the undergraduate programs. In terms of a faculty, you'll see some of our faces later as well, but we're a very diverse group in our department, and that's also exciting. We have a lot of great faculty. So next slide here. Right, so Boston, there's, a lot of great places in the world to study and to study engineering and chemical engineering in particular, but Boston is especially excellent as an academic location, but also as a biotechnology and pharmaceutical hub. We have lots of material companies in the area as well, and our students go and work with all of these companies. And so it's really a great place to work in collaborative research environments. A lot of faculty work with research hospitals in the area as well, because we have a great many of them available. So in a moment, we're going to now watch a short video on the Northeastern educational model in general.
Our approach to learning is very simple, very powerful, and very impactful. It's called experiential education. It helps you integrate the classroom experience and the world experience. You're not only thinking, you're doing, and you're bringing the two together.
Co-op got me to see the real-world application of what it is that I'm learning.
You get the more structured class learning to really get the initial concepts in your head, but then you get a chance to go on co-op and actually getting your own hands-on opportunities to try them for yourself.
And that just getting to swap back and forth between that it's intoxicating, honestly. It was like, it allows you to hone all these different skills at the same time.
You're coupling their new theoretical knowledge from taking more classes with their increased lab experience, and it's really, really powerful.
I was able to learn the process of research, which was cool, much different than a lab experience. Although a lot of the stuff I learned in lab, I was able to take with me.
To now be able to know exactly what questions I need to ask, what research I need to do, and just hit the ground running.
They gain a level of confidence that they wouldn't have necessarily received had they not had that professional experience. They also gain this level of professionalism that I see gets translated back into the classroom.
I think I understand how to study better and how to learn better and how to apply what I'm learning into different applications that I think I might have had a disconnect with before.
I have a high hiring bar. The program and the results that we see in that time is, we can't compare it to anything else.
My advice, go to the International Co-op office. They'll help you find one in Asia. We have many students doing co-ops in Asia.
So it was kind of interesting just to see the values in China that some of the patients had and their families had.
Being in Portugal really helped me develop my language skills.
Realizing that there's so much more out there in the world. I think Northeastern caters their program to allow each student to have a lot of flexibility.
You really make your own experiences.
Okay, so that's a quick look at our experiential model, university-wide. It really is built into our ethos, and we do a lot to prepare our students for these co-ops rather than just, letting you do them. We prepare you for them. Next, we're going to hear another quick video on specifically the Department of Chemical Engineering. So you'll hear from our current chair of the department, Professor Becky Willits, as well as some of our other faculty and students.
Chemical engineers can solve any of the world's challenges. Climate change, health, medicine.
How do you build a sustainable world?
All these different things that our future as a planet depends on, everything can tie back into chemical engineering.
The master's program is really coursework or research, where you get a little bit more in depth than you did as a bachelor's student. And then the doctorate is really all about research.
Research facilities here at Northeastern are great. We have world-class equipment and capabilities.
My research focuses more on examining the endothelial calyx in organ-specific cancer metastasis. It affects many people. Many people have died from it, and so obviously there's such a need to find a cure.
Batteries, they produce a lot of heat, and if we're going to put it into an electric vehicle, we have to get different ways of removing that heat efficiently. Otherwise, we're going to see them flare up. My research is how can we improve polymer materials? How can we make these battery packs safer? And how can we make them more cost effective?
We spend a lot of time thinking about what allows our students to be their best selves and to pursue their own dreams and their careers.
Northeastern has the experiential model.
You're in charge of your own project. You have your own timeline that you create and the goals that you want to do.
We're embedded in this ecosystem that is really looking at how do we advance technology for health, for energy, and for climate.
Boston is a biotech hub, so there's so many pharmaceutical companies, and I was thinking about future career opportunities when I decided Northeastern.
That idea of finding where you want to be is just experiencing something before you do it and commit to it is just a really exciting opportunity. And so we encourage our students to do co-ops.
And then they come back with new knowledge, and they've learned things that I wouldn't even think to teach them.
My co-op is at Rogers Corporation. When you get back into the field, you know exactly what to do because you've seen that before. You have the thought process down, you know where to go.
What's so great about Northeastern is just so much collaborations between different departments.
This is the most supportive community I've ever been in. Academically, professionally, personally, there's always someone there to support you, and they just want to see you succeed.
Okay, so we can go to the next slide. So I'm going to walk through a few of the particulars, but not really an in-depth look at each of our degree programs that we offer in the college. So we'll start with a quick look at the Pharmaceutical Engineering MS program. We had a separate webinar on that program explicitly this morning, so find that video recording if you would like to learn more about it. But we'll just do a quick look at it. So the next slide. So this is really focused on engineers that want to expand into the pharmaceutical sector and or people that are coming from the pharmaceutical sector and want to really get more involved in the engineering aspects of that industry. And the idea here is that, if we go to the next slide here as well, this is a cross-college interdisciplinary major, and it's coursework only at the master's level, so no PhD equivalent. And it is 32 semester hours, can be completed in 1.5 to 2 years, mainly depending on whether you do a co-op and how quickly you move through the coursework. Can be done part-time as well. And the core courses are split between chemical engineering and also pharmaceutical sciences. So you get to see kind of both aspects coming into play from science as well as engineering. And then you get to integrate these experientially as well through co-ops, but also in lab classes. So it is an on-ground, not online program, because we do have 6 semester hours of lab classes required for that course. And then we can go on to the next one. So this will then focus on the chemical engineering master's and PhD programs, which we do have in the department. And we'll go to the next slide. We'll start here with the master's programs in chemical engineering. So the MS in chemical engineering program has 3 concentrations available. So we have 2 coursework only concentrations. So you can get a master's in chemical engineering with a concentration in biosystems or a concentration in sustainability. And the idea is there you're going to have some core coursework that is basically math and numerical methods and programming based. And then you're going to have depth focus on your particular specialization area, and then some broader electives to explore other topics and aspects as well. And then we also have what we call our chemical engineering principles and applications concentration, which is either thesis or research project track. So either way, you're doing research in labs, and a thesis is you're going to publish a full thesis and defend that before a committee. This is the typical MS with thesis degree. That is a very powerful degree to have. The project level is if you don't want to actually publish that document and spend 8 semester hours on that, you can get a less intensive but still valuable experience doing some research with one of our faculty members. And similarly, it's going to have the same numerical and math and programming core as the other concentrations, and then these 8 semester hours of thesis and project coursework, as well as some other core courses that are going to help prepare you to move on to a PhD program later. You can finish with just that MS degree with thesis, but a lot of times folks are using that to take the next step into the PhD program. So then we can take a look at our PhD program next. And the idea here is this is going to be a relatively traditional PhD program for chemical engineering. We're going to have 4 core courses. These are going to be typical areas that you have already mostly studied, which are going to be transport kinetics, advanced math, and then also thermodynamics. And then from there, you take 8 semester hours of elective coursework. We have lots of options available each semester. And then you're also going to do 8 semester hours of professional development and research prep to lead into your proposal defense. Once you've passed your proposal defense, then you're officially a PhD candidate, and you then spend the rest of your time in the program working towards your dissertation defense. That proposal defense typically happens at the end of the 2nd year, is the goal, but there is flexibility there. And then that dissertation defense really depends a lot on you, but is going to be typically at the 4 to 6 year mark. And then, if you hit the advance, we have some other notes. Just advance, put them all on there. So we have also, with our PhD program, you've heard in the video, you can still do a co-op even while you're on PhD. So students do that. Most of our master students go on co-op. And there are lots of other certificates available throughout the university that you might also be able to participate in. Some of the popular ones, we offer one in the department on process safety. And then there's also one offered to the College of Science and Nanomedicine, which also tends to be attractive to some of our students. There are others in engineering management and engineering business. Really lots of options to consider. And It's also possible to switch from the master's track to the PhD track, but you should understand that if you are applying for the master's program and you're admitted to the master's program and you come here and enroll in the master's program, then you're here to get a master's degree, right? It may be possible to switch over to the PhD program if you're doing great research and working with a research advisor and doing that thesis track MS degree, and that advisor wants to switch you over to the PhD. But no one should expect to switch over to the PhD once they're here if they are in the master's program. But it might happen. It's possible. From there, once you're in the master's program, you can always just apply to the PhD program and get admitted just like everybody else. For those coming into the PhD program, we do have advanced entry where you're able to waive up to 3 of the 4 core courses in our program if you have already taken equivalent coursework elsewhere, like in a master's degree program. And then we can advance. And so at this point, I'm going to turn it over to Professor Daramola, who will talk a little bit more about the research activities we have going into the department and opportunities for students.
Thank you, Adam. Hi, everyone. Morning, afternoon, or evening, wherever you are. As Professor Nkasaya said, I'm Professor Daramola, Research Active Faculty in our department. My work and my group, we focus on using a variety of techniques to reverse the impact of chemical engineering processes and processes in general on the environment, right? So if you think about our field of chemical engineering, there was a significant expansion of the field and growth in the field due to the advent of fossil fuels and how we could take those fossil fuels and make them into energy or make them into products. And now we're learning that all of this has caused some issues, in terms of waste management and carbon emissions. And so our work focuses on trying to reverse that using the same principles that you will learn from classical chemical engineering. So with that in mind, you can imagine that my research area, for example, will cover areas in complex computational systems to try to understand how processes work. Our group also looks at either understanding materials or generating materials to drive some of these processes. And we focus as well on energy and sustainability. And aside from, what myself, as you see when I introduce my other colleagues, all our work individually covers these 5 research areas that you will see. So there are researchers, and in a lot of cases, our faculty are multidisciplinary. So you don't just have someone working only in complex computational systems. They might use complex computational systems to understand biomolecular and biomedical systems, for example. But these 5 research areas are the key areas that our faculty work on. So in complex and computational systems, you have everything from trying to understand how atoms interact all the way to how you might simulate an entire plant, for example. In materials and nanotechnology, there's a focus on creating and evaluating novel materials for applications in healthcare, for applications in electronics, and for applications in environmental remediation, as well as things like energy storage, for example, batteries. In energy and sustainability, we have a variety of faculty working on understanding how we can, aside from improving energy storage and water delivery, also trying to understand how to recover and remediate some of the emissions due to the way in which we generate energy today. We have a variety of faculty that work on biomolecular and biomedical systems, everything from bacterial modification all the way to some of the research in glycocalyx that you saw earlier. And then one of the unique things I'll say about the department is that we also have researchers that are focused on understanding how to make better engineers, right? How do engineers study? How do people identify as engineers? And what are the things that we can do to make that learning process better? And so these are the 5 research areas that the department broadly works in. Next slide, please. And so on this slide, you see all the faculty, the core faculty in the department, both research active and teaching faculty. This year, we've brought on 4 new faculty members, 3 that will be research active and 1 that will be teaching faculty. And so these will be the core faculty in the department. Some of them are jointly appointed, like myself, between, say chemical engineering, for example, and bioengineering. Some people are between chemical engineering and say chemistry and chemical biology, for example. Next slide. In addition to our core faculty, we also have affiliated faculty as well. So these are faculty that work in other departments like chemistry or biophysics or civil engineering, but they can also advise students within our departments because of their research overlaps, right, with the research going on within the department. So you can get a sense that, you can do research that is core chemical engineering, but has some adjacent interests in other areas. So if I use the example of what I talked about with environmental remediation, it's not just the processes that matter, but also thinking about how that process fits into the entire ecosystem of the environment. And so you might imagine that research overlapping with, someone who studies environmental engineering, for instance, in the civil engineering department. Next slide. Okay. And so typically when you come into the program, we have what are called rotations, which is when you will spend, the first 3 months meeting with faculty, getting to tour their labs to better understand what their research is, because it's one thing to read something on paper on a website and actually to see it real time. And you also get a chance to attend lab meetings as well, learn about the other students within the group. That way you can, start to figure out, okay, I have this research that I would like to do, but I can see that my area overlaps best with this faculty member versus this faculty member. And the idea is that you'd have done your research beforehand before this happens. And so after the rotations, the prospective candidate then thinks about who their choices for potential advisors are, and there's a match made between the potential choices for the student as well as the potential advisor who's the faculty member. And most students are placed with their first choice. Again, that choice and that placement is a process that we do, and we're going through that right now. So at the end of this year, the new students who are incoming will be assigned to the faculty member. And so students can have more than one advisor because there are situations where, again, your topic might be better suited for multiple faculty to assist you. Maybe you want to do both experimental and computational work, for instance, right? You can imagine that you might want to co-advise. If your main advisor does computational work, perhaps you might have a co-advisor who does experimental work to guide you in that area. You could also have an advisor outside of the department. So I showed you a list of affiliated faculty there who are not in the chemical engineering department, but they are affiliated with the department. And then, in trying to make sure that we match the timeline for your studies with, your timeline to graduate. In some cases, we can give an extension on choosing that advisor, but typically students are matched with advisors within that first semester of their arrival. And so you can learn more about the faculty and the different projects they work on by going to our chemical engineering website, and those pictures that we showed you of our diverse faculty, you can get a chance to see what the actual projects that they work on are. Next slide. In addition to this, there are also opportunities for graduate students to get fellowships. Some of these fellowships are they are US-based fellowships, and so there's specific criteria for them. So some of these include the National Defense Science and Engineering Graduate Fellowship. There is the NASA pre-doctoral fellowship program. There's probably the largest one, or the one that funds the most students, is the National Science Foundation Graduate Research Fellowship Program. So there's a variety of these as well, and one of the things that our department is great at is providing support to develop these applications. And so I'll give you an example. A recent student who is currently a PhD candidate doing rotations, I mentioned to them that this was something that was an opportunity for them to think through. For instance, with the NSF, you don't have to, you could base your application, for instance, on prior research that you've done. And so that student was able to work with the communication lab and make that connection to help guide them to write that application, because sometimes these things can take quite a bit of time. And so our department and College of Engineering in general is great at facilitating that process for potential candidates. So this could be something to think through as you start to think about how you would like your research program to go. Next slide. Okay, and so with that, I'm going to hand it over to Mallory to tell you more about our graduate student community.
Hi guys, my name's Mallory. I'm a third year chemical engineering PhD student in Allison Dennis's lab. So if you remember from the picture, she is the top right corner. We can go to the next slide. This year I've been serving as president of our graduate student council. This is our e-board as well. We just held elections, so our time is pretty much up. But our role is to kind of serve our graduate student population as a whole. So we do that through social events. So we did our first ever formal, which was really fun. We have an upcoming potluck literally tonight. And then we have our academic and professional development committee where they work on doing writing workshops. We're starting to add in some things like how to adult. So next semester with how to do taxes and all that stuff, because most of us when we got here had never done it ourselves. So we're really excited about that. And then we're also integrating more volunteering and outreach programs into that as well. So we can go to the next slide. Now, if you're not interested in serving on student council, that's totally fine. There's a lot of different professional organizations on campus, including GWISE, AICE. I believe there's now a biomaterials group. So there's a lot of different opportunities in terms of professional development, as well as other councils from the College of Engineering. And then there's a bunch of different resources on campus. We've already mentioned the Comm Lab. We have a couple of our students serving as writing fellows, which is a really great opportunity to also give back. And there's a bunch of different organizations for multicultural, because we have a really diverse department. So those are always really encouraged to join. Next slide.
Okay, I think I'm going to hop in real quick. Thank you for all of that from everyone in chemical engineering. I just want to expand a little bit on some co-op support that is available for students that are interested in that route. We have co-op coordinators that you will work with during your time of applying for co-op and moving through your co-op if you were to receive one. They teach cooperative education courses, and they offer a ton of workshops, including global co-op, a speaking club for international students, how to self-develop a job, and more. They provide one-on-one career advising based on what your areas of interest are and what you want to sort of get out of your co-op experience. And they are also responsible for developing our employer partnerships and adding to our over 3,000 company list of co-ops that we currently work with and offer to our students in the College of Engineering. Other offices of support for anyone who is coming to Northeastern include our Office of Global Support for CPT advising. Anything that you need as an international student, that is an office that is going to be your best friend through your time at Northeastern. Student Services is available for academic advising. The Global Student Success Office is available for international students and offer things like tutoring, workshops, and webinars to help with the transition to Northeastern. And then our career design and employer engagement opportunities that we offer at Northeastern include career fairs, workshops, and career advising appointments to help you with sort of the next step of your career as you move through your time at Northeastern. We also have within the COE our graduate student ambassadors. Mallory is our chemical engineering graduate and ambassador, but we have an entire team of ambassadors for every program within the College of Engineering who are available to answer any questions that you might have about moving to Boston, what it's like to be in the program, classes that they've taken, anything about the student experience. They are without a doubt the best resource we have to talk about that hands-on experience. We have an ambassador website, as well as a ton of social media platforms, including WhatsApp, Weibo, and Instagram. You can find us on there COE graduate student ambassadors is going to be the easiest way to do that. They also respond to our student inquiry form, which is found on our admission page. Their email is listed below should you have any questions that you want to send after this webinar. If you've attended a couple of webinars and seen a couple of different faces, or you're wondering who to reach out to, that QR code will take you to our website for the COE graduate student ambassadors, and you can find our ambassadors with the corresponding department if you have any department specific questions to ask them at that point. I'm going to pass it back to Mallory real quick to talk about leaders.
All right, I'm back. So Leaders is another form of co-op, but is separate from the co-op program. So Leaders is specifically for PhD students only, and it integrates coursework to learn about project management, which is super, super helpful, especially for PhD students, because we are essentially our own project manager. It's just you're like a department of one, or potentially more if you have undergraduates who work with you. So it's a really, really great program. And so you don't have to actually go on a placement, which is what they call the actual like working like your co-op. If you're interested in just learning how to do project management and like better yourself in terms of leadership skills, you can just do the coursework. But if you're interested in actually going on placement, that's where you do like the actual phase 2 and 3, in which you have a number of people through this, like through the PhD network. So you have multiple people who assist in finding you co-ops. So you fill out like a big form saying what you're interested in doing and types of companies you're interested in working with. And then there are 2 women, Wendy and Terry, who go over those and actually like hand place you and like when companies are a good fit for you. So it's a really great opportunity if you want to just learn about project management, but especially if you're looking to do some sort of co-op placement.
Again, I know this was a ton of information today, and you probably have more questions than are even in the Q&A right now. And so just really want to encourage everyone on this call to connect with us. There's a link to our faculty directory to learn more about them and what they're doing, as well as a bunch of department-specific social media as well to keep up to date with all things happening within chemical engineering. I'm going to give a very quick overview of co-op. I know my colleagues have talked about it a little bit so far. And cooperative education is the backbone of most of Northeastern University. Students are able to gain real-world experience as part of their academic curriculum, a real 2 birds, 1 stone, if you will. It is available for undergrad and graduate level co-op opportunities. Like I said, we've got over 3,000 co-ops available, partners that we work with. You can see all those numbers there of the number of students that are taking advantage of this part of our cooperative education model. It is very popular within the COE. And here is just a very small smattering of the companies that our students go and work with on those co-ops, but the list is much more extensive. And again, we're really proud of that. #1 ranking for co-op and internships for students. It's really in the ethos of what Northeastern likes to offer. What are the characteristics that define a co-op? We are looking for job functions that are going to align with majors within the College of Engineering. Work must be available full-time, that's 35 to 40 hours a week at the employer's office. And the co-op can be anywhere from 4 to 8 months, depending on what that company is offering and the time of year that you are joining them, whether that be spring, summer, or fall. The industry is flexible. Co-op is a paid experience, and it is recorded on your transcript as a non-credit course. Again, the benefits we think are numerous. You can advance your skill set and explore your interest within a professional setting. You're learning firsthand applications within your chosen field and developing valuable job search and interviewing skills just by going through the process of applying for the co-op. You're taking that co-op class, you go and you interview with these different companies. And so you're really sort of honing your skills and being able to communicate what it is that you are looking for and what you're bringing to the table. You're able to connect and apply the things that you are learning in the classroom, that classroom theory, to a real world situation with these companies that you're working with, and able to grow professionally and personally while building out your resume and CV. You're able to make connections and build out your professional networks while you're still in school. Really helps with that sort of launch into the professional sphere after graduation. And the salary range is anywhere from 18 to 41 per hour, depending on the company and the industry that is in there. And it utilizes CPT in the US, or you can work globally. That is a lot of information, I am sure, just over co-op and Northeastern and chemical engineering in particular. And so now we're just going to talk a little bit about actionable next steps that you can take if you have not already put in an application with us. This is a bit of a roadmap of what the process will look like once you have received your admit letter. You can kind of see each major checkpoint that you want to make sure that you're touching base on. That includes connecting with your program coordinator and your student ambassadors, and paying your enrollment fee. That is going to be the first step there. You'll activate all of your Northeastern and Husky email accounts, and then you start your health report to get all of your vaccinations in to be able to come to campus. For any international students, this is going to be a great time to also make sure you are applying for your I-20. The Office of Global Student Services is going to be your best friend through this process, really helping you with any of those international paperwork things that you need to get done. You'll start looking at housing from there, and then plan for orientation attendance. And that will lead you to course registration, paying tuition, and submitting your final transcripts and proof of degree before you start grad school with us. So again, if you have not put in an application with us, we would love for you to submit an application. You can see all of our Spring 25 application deadlines for Canada and the US. We do have some campuses in Canada. It's not really going to apply to anyone here who is looking at chemical engineering. As well as our dates for fall 2025 admission. I want to highlight that December 1 deadline for all PhD applicants, in case you didn't see that in the dropdown. All of those dates are also available on our website. So if you have any questions about what category you fall into, it's all going to be on that COE admissions page. The admissions requirements include 2 letters of recommendation, your unofficial transcript at the time of application. Again, we don't need that final transcript till after a little bit further down the pipeline with us. A statement of purpose, resume, and any English proficiency test score that you need to provide based on the location of your undergraduate degree that you completed. We are also currently GRE optional at this time, so that is not something that you need to submit to us. I'm sure you can see at the top of the page our application fee waiver code. That is going to save everyone who attended this webinar with us this morning $100 on their application fee. So it is that Apply COE 2025. I just want to point out that that is case sensitive, and you'll want to enter it exactly as you see it here on screen. And you'll want to make sure you enter it at the correct time in your application online, because if you go past it and you get it submitted, you cannot retroactively add this code. All of that is sort of highlighted here. It's going to pop up on the applicant information tab. You're going to go past the yes/no questions and answer yes to the question asking if you have a fee waiver code, and you need to enter it then to make sure it will credit on your application itself. Again, case sensitive, exactly as it appears. So give everyone a minute to just grab that real quick, make sure they're ready to go. And that is bringing us towards the end of our time together. We would love for everyone to keep in touch. Again, COE is online and on social media. You can find us in a lot of different places to keep in touch and keep up with news and activities and communications coming out from the graduate admissions team. The admissions office can be reached at the email below, as well as our student ambassadors at the email listed there as well. And I believe that is going to take us into our Q&A. We are at about time, so I don't know that we're going to be able to get through all of the questions listed in that Q&A, but again, you can reach out to COE grad admissions or the ambassador team if we're not able to get to your question today. I'm going to ask.
Gretchen, can you address, there's several questions about if there's any way to use the waiver code after they submitted an application.
If the application has already been submitted, it cannot retroactively be applied to that application, unfortunately. I am not able to pull up the Q&A right now. Are there any other questions in there that we're able to go through? I don't know if you can see it better than I can, Adam.
Yeah, so several on the waiver code. Let's see, I've answered a bunch of them.
Awesome.
If you're advised by a CUNY affiliated faculty member, is it required to be co-advised with a CUNY core faculty member? Now, usually we do like to see that, so that you have someone based in the department to anchor your studies. But you can always check with us once you're here too. Let's see. Yeah, some more waiver code questions.
I'm going to go ahead and stop our share and then
For
be able to look
recommendation
at that too.
letters, no, they don't have to all be from academic professors. They can be from other people that have known you or worked with you. They probably ought not be, personal friends or family members. You need someone that can speak to your professional qualifications and ability to get things done. And I think there's still a lot of more questions coming in, but do we have more time, Gretchen?
I think we are about at time. Again, that waiver code was apply COE 2025 to anyone who missed it in there. I'm sorry about it not being able to apply retroactively. I don't make the rules there. If there are any other questions, I definitely would encourage you to reach out to the COE grad admissions team through that email that was listed, or you can reach us on our website as well. Again, if it's anything that's maybe a little bit more specific about the program, our ambassador team is a really great resource for that. So I just want to say thank you again to Dami and Adam and Mallory for joining me today. Thank you to all of you who came and participated and listened to everything that chemical engineering has to offer. And we look forward to seeing your application. Thanks, everybody.
Thanks, everyone. Good luck.
Bye.
Bye.